Howdy folks, welcome back. So in this video, again, I'm just going to go through the practice quiz 6. I think that's the number we're on. And again, show you how I go about solving the different types of problems. Again, I recognize it's by no means the only way. In some cases, it might not be the way that works best for you. If you have another way that works better for you, that's fine. As long as you end up with the same answer at the end. You don't necessarily have to do the exact route that I took to get there. All right, so this one's going to be a little bit different. There's only 2 questions on this quiz, but the second question is fairly involved, so that'll make up for some of the points there. All right, so the first question is dealing with finding the maximum or minimum of a quadratic function. So here you have a quadratic function, in this case, dealing with projectile motion. So you have a toy rocket is launched straight up from the top of a building 50 feet tall at an initial velocity of 200 feet per second. So therefore, the equation that models this is given here. So you have s of t equals negative 16t squared. Again, that comes from the acceleration due to gravity on Earth. Plus my initial velocity, so 200 times t, plus my initial height, which is going to be 50 there. All right, and we're asked, what is the time at which the rocket will reach its maximum height, and what will that height be? All right, so again, when you're asked to find the maximum or minimum of a quadratic function, it's just a fancy way of talking about finding the vertex. All right, so when we find the vertex, we found the maximum or minimum. All right, so again, the vertex is going to be the point HK. All right, where h is going to be negative b over 2a, where the b and the a have the same definitions with the quadratic equation there. All right, so in this case, negative, and b in this case is 200 divided by 2 times a, which is going to be negative 16 in this case. All right, so we have, let me plug that into our calculator here. We have negative 200 divided by 2 times negative 16. So we end up with 6.25. And h represents our x, which in this case is t, so that represents our time there. All right, so then to find the height, we're just going to evaluate my function at that time value. All right, so my k is going to be s of 6.25. So I'm just going to plug in 6.25 wherever I see a t in my function modeling my situation here. So we have negative 16 times 6.25 squared plus 200 times 6.25 plus 50. So negative 16 times 6.25 squared plus 200 times 6.25 plus 50. So that means that our maximum height is going to be 675 feet. All right, so the next question here is dealing with zeros of polynomial functions. All right, so you have a polynomial function f of x equals x to the third minus 7x minus 6. All right, so the first step is just listing the rational zeros. So use the rational zeros theorem to determine the possible rational zeros for the function f of x. So those are those values, p over q, that we need to check to find the rational zeros for my function. All right. So so my values for p, so my p is going to be the factors of my constant term. So in this case, the factors of negative 6. So that's going to be plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. So those are the numbers that I can multiply together to get 6. And then q, those are going to be factors of my leading coefficient. So in this case, my leading coefficient is 1. So those are just going to be the factors plus or minus 1. All right. So then the values that I need to check are these p over q values, which again, if we divide anything by 1, it just is itself. So we're just going to have plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. All right, so yeah, so the next thing is stating the rational zeros for the function. So we just have to plug in these values into my function up here. And if it equals 0, then it's going to be a 0. If it doesn't equal 0, then it's not going to be a 0 of the function there. All right, so you just have f of 1, f of negative 1, f of 2, f of negative 2, f of 3, f of negative 3, f of 6, and f of negative 6. All right, so this part can be a little bit time consuming. So I'm going to go ahead and, well, I'll go ahead and do the first one, and then I'll probably pause the video while I do the rest there. All right, so in this case, yeah, so we have 1 to the third minus 7 times 1 minus 6. So that's negative 12. So 1 isn't going to be a 0. So then if I try negative 1, that does end up being 0. And so on and so forth. So I'm going to go ahead and pause the video while I go ahead and check the other ones, and then I'll be back shortly. All right, so once you've gone through and figured them all out, again, this is a third degree polynomial, so we should have a maximum of 3 unique zeros. So yeah, so once you've found, again, whatever the degree of your polynomial is, once you've found that many zeros, you don't need to check any more numbers. So that might help shorten things up a little bit there. All right, so yeah, so in this case, our zeros are going to be negative 1, negative 2, and 3. So we have negative 1, negative 2, and 3. All right, so the final question here is dealing with factoring the function. All right, so you can use the factor theorem. I think it's called the factor theorem there. So if k is a 0, then x minus k is a factor. All right, and since we found all the zeros here, we can factor it relatively simply here. So you have f of x, so we have x minus k, which is minus negative 1. Then we have x minus negative 2. And then we have x minus 3, which we can simplify as, so we have x plus 1, x plus 2, and x minus 3. All right. And yeah, so again, that's how I go about solving problems. Again, I recognize by no means the only way. So if you have a way that makes more sense to you, again, as long as you end up with the correct answer at the end, you can follow that route as well. Again, as long as we arrive at the same destination. Hopefully you found this helpful. Have a lovely day, and I'll talk to you later. Bye now.